All right, let's get right into it. Today we're looking at a huge breakthrough in how we make AI models not just powerful, but also helpful and safe. It's a really cool story about how researchers took a super complex problem and found a solution that is, believe it or not, incredibly simple.
Okay, so here's the million-dollar question, right? You've got this massive AI that's basically read the entire internet, the good, the bad, and the weird. How on earth do you teach it to be a good citizen? How do you get it to pick out the helpful, truthful stuff and just ignore all the junk?
Think about this for a second. An AI knows that, say, half the population believes something that just isn't true. So what should it do? Should it repeat that myth as fact half the time just because it's popular? No way, right? That's the last thing you want.
And that right there, that's the core challenge of what we call AI alignment. For a long time, the best answer we had for this was a process that was, well, brilliant in its own way, but also a total headache to manage.
So let's talk about the old way. Reinforcement learning from human feedback, or RLHF for short. This has been the gold standard, the engine behind a lot of the AIs we use every day. But as you're about to see, it's kind of like a crazy Rube Goldberg machine.
Okay, stick with me here, because it's a three-ring circus. First, you start with some basic training on good data. Simple enough. But then, stage 2, you have humans sit there and rank different AI answers from best to worst, and you use all that ranking data to train a completely separate AI to act like a judge. And then, in stage 3, you use that judge AI to give the main AI little treats or rewards every time it says something the judge likes. It's a lot.
And this diagram just lays it all out, doesn't it? You can really see all the moving parts. You have to collect data, then build a whole separate model, then use that model to train your original model. It's a complicated dance for sure.
And look, don't get me wrong, this whole Rube Goldberg machine works. It gives us amazing results. But, and it's a big but, it is a monster to handle. It's complex, it can be really unstable to train, and it costs a fortune in computing power.
But what if we've been overthinking it this whole time? What if there was a shortcut hidden in the math, a secret that could let us skip all the most complicated parts? What if the solution was hiding in plain sight?
And then, some researchers at Stanford had this total aha moment. They put it perfectly in their paper with this one sentence. It's an incredible insight. Essentially, they realized, you don't need to build a separate judge AI because the language model you're trying to teach can already be its own judge.
So the big idea here, and yeah, it involves some really clever math, is that there's this direct hidden connection between what the model does and what we want it to do. This means we can just throw out that entire build a judge step. We don't need it. The model has everything it needs to learn right from our preferences.
And that one simple insight unlocks a whole new, much more elegant approach. So let's talk about direct preference optimization, or DPO. Just look at how clean this is. DPO takes that secret connection and turns that crazy multi-stage process into one single elegant step. You literally just feed the human preferences, the I like this one more than that one data, directly to the model. Boom, done.
Okay, this is the money shot right here. On the left, you've got the old way RLHF with all those boxes and arrows and loops. It looks exhausting. And on the right, DPO, clean, direct. The difference is night and day, isn't it?
So how does it actually do this? Well, you can think of it like this. It turns this whole messy alignment problem into a super simple this, not that exercise. The model just learns to dial up the probability on the answers humans liked and dial down the probability on the ones they didn't. It's that direct.
All right, so it's simpler, it's more elegant, that's great, but here's the real test, right? Is it actually any good? I mean, simpler is nice, but not if the results are worse. Let's look at the data.
And wow, the results are pretty amazing. They tested it on summarizing text, and the old complex method, RLHF, won about 57% of the time. But DPO, the simple one, it won 61% of the time. So not only is it easier to use, it actually got better results.
And it wasn't just a fluke. When they tested it on generating dialogue, DPO was the only method that was both efficient and smart enough to come up with answers that were even better than the best examples the humans had picked out. That's a huge deal. What's really cool is how it gets these results. It's more efficient, it figures out how to give the best answers without having to drastically change its personality, so to speak. It learns the new rules without getting amnesia about everything else it knows. And that's exactly the sweet spot you're aiming for. Okay, so let's pull back for a second. This is more than just a cool technical trick.
Why is making this process simpler and more efficient such a big deal for the future of AI?
So let's just recap the wins here. DPO is stable. No more of that shaky reinforcement learning. It's a top performer, matching or even beating the old method. It's way lighter on your computers because you're not juggling multiple AIs. And the big one, it's just so much simpler to actually implement.
And here's why that simplicity matters so much. This isn't just about making life easier for big tech companies. It lowers the bar. It means smaller teams, university labs, maybe even a single smart developer in their garage can now properly and safely align an AI. It opens up the field to so many more people.
You know, this breakthrough just completely streamlines a huge bottleneck in building good AI. And that leaves us with a really exciting question to chew on. Now that this critical piece of the puzzle is so much easier to solve, what's next? What bigger, harder problems can we finally start to tackle?